Yes, see
Yes,
and hear you.
yes,
Welcome.
uh, yes. Thank you very much, dear colleagues. This presentation with the title "Machine Learning-Based Failure Rate Identification for Predictive Maintenance in Industry 4.0." It is the example of application of some modern approach to the classical problems. We will consider well-known problem of the identification of failure rate in the large-scale systems, with methods of so-called kernel-based machine learning. So we will consider the typical problem of failure rate regression model building and propose the idea of construction of the regression models of high dimensional with difficult connected with a complicated structure of the dependence from the failure rate from the initial parameters. The development and implementation of smart manufacturing based variety of real-time information collection equipment, such as sensors networks, provides the opportunity to significantly improve efficiency of quality control in order to prevent both production and economic losses. So, the possibility of obtain a large amount of information give us the possibility to construct the models of high accuracy and very difficult from the point of view of the dimension. So we will propose the methods to the construction of the regressive models of the without necessary to find the basic structure of this model. Among the problems of production management, an important place is occupied for preventive maintenance, which is an effective tool for reducing costs associated with failures and interruptions. Predictive maintenance, of course, is a key factor for ensuring the reliable operation of our machine control systems. And in preventive maintenance implementation, failure rate is widely used as an important metric for evaluating equipment reliability, whereas failure rate prediction is an effective way to maintain decision making. Greatest interest in the development of methods for predicting failure rate using their models, which take into account the influence of various technological and operational factors controlled during system operation. It is a classical problem. First work in the field of identification of failure rate was done about maybe 50 years ago from the classical works of Professor Mikhail Stabinetsky from Kharkov. He proposed the first approach to the regressive model building of the failure rate. Now this approach is implemented by middle multivariate regression model to estimate the relationship between effective factors predictors of coverage and failure rates. But a common approach to building regression models involves pre-selecting of model structure. It is the most important and most difficult problem because it is necessary to find a structure of this model in order to obtain first high accuracy of approximation, and the second take into account the restriction of our data and a priori information. In fact, typical approach to this problem, it is first parameterized functional relationship between the output variable and effective variables. It followed by statistical estimation of unknown model parameters on model training. Thus, it may be statistical approach, for example, maximum likelihood, mean square errors, and so on. And the second one, model training, it is machine learning approach to this problem. The main problem lies in choice of model structure, the complexity of which should correspond to the amount of data available for trained model. In this paper, we propose the approach of kernel-rich regression machine learning, and the main steps of obtaining the model of failure rate, it is first data preprocessing aggregation. The second one, it is model training along the regularization and smoothing, and of course, model verification and validation. Problem statement. We will consider the typical statement of identification of the failure rate. So we have some structure of this model. We use the typical model as a parameterized quasi-linear model, which may be represented as a dot product for the vector of the coordinate functions and vector of unknown parameters. So step is the find of coordinate function. For example, it may be polynomial function and so on. And the second step, it is the estimation of unknown parameters. It is classical approach. In matrix vector form, we have the measurement equation. And the second step, of course, it is obtain the estimation of unknown parameters. Classical approach, for example, using ordinal least squares, and we obtained the results as the optimization of the quadratic functional, and well-known results as the estimation of known parameters. But the main problem is, first, it is a rational choice of coordinate functions, because if the dependence of the output function of the dependence of the failure rate from the affected factors is very complicated, and we have no a priori information in order to describe this dependence, the choice of the coordinate function is very difficult. For example, when they use typical classical approach, for example, polynomial regression, it is a problem to find degree of polynomials which are used in this field. And this problem is very difficult because it is necessary to obtain solution in the two steps. First, estimated of the unknown parameters, and another step, it is a find of construction regression which most suitable to our data. When they use the approach connected with the machine learning, they may propose the idea of use kernel models in such a way it is not necessary to construct the polynomial structure, for example, of regression, and for, the structure of file array regression models will be the following. Excuse me. First, we proposed two choice of coordinate functions, so it with dot products with the kernel function. It is a classical approach. We describe in a lot of work in the field of machine learning and demonstrate very efficient in the situation. Then we have no a priori information about what function we want to identify. We use the radial basis function, kernel function, that is, of course, typical structure of kernel models. And the results, they obtained the regularization functional in order to find the parameters of the kernel models. The solution of this optimization problem is demonstrated here using the classical approach, of course, Lagrange function with rich term width ensures the possibility of regularization of such a problem. We find the estimation of known parameters in the as a structure of rich regression call models. It is very important that the results of estimate doesn't included the coordinate function. So we only construct model as a linear combination of the kernel functions in the point which we include in our trained data set. So in such a way, we obtained another problem. The number of kernels which used to determine the number of points in data set, this result in have the property of spatial oscillations. So from it is necessary to take a large amount of kernel function in order to obtain high accuracy, and from another point of view, it is not necessary to take a very large amount because they have the very properties of so-called spatial oscillation of a result function. To do this, we use the additional regularization using data graph models. Describe the some adjacent graph consists of nodes which all observe data points wherein the age connected to nodes is weighted by kernel function, which reflects data cloud geometric structure. This is an example of such type of regularization of our problem, which use another regularization term which describes the structure of initial data cloud. And as a result, they obtained the smoothing kernel regression model. This data-dependent kernel corresponded to the so-called semi-norm of our regularization term. This is a result of solution. It's very simple. In order to obtain the results of the regression model in such a case, it's necessary only to solve a linear algebraic equations with uh, only kernel matrix as a basic matrix of these equations. From the computation field of view, it is very easy to obtain the solutions, and as results, we obtain the structure of our model. Example, we illustrate this approach with a computational experiment with case study. This is a data from real semiconductor manufacturing industry. This data set is provided for experiments in machine learning for these applications. And this is the data set which we use. Data set contains data collected during semiconductor manufacturing process and represent a series of monitoring signals from sensors and process manufacturing points. This is a preliminary analysis of data. Yes, first of all, data set consists from 1,500 examples, each with uh, 300 measured features. So the dimensional model may be very large, only 100 of examples represents furrows. So it is necessary at first to do some preliminary analysis of data and pre-processing data cleaning. It is typical step in machine learning approach. It is the illustration of histogram of first 9 sensors. It is a covariance matrix heat map which demonstrates very complicated structure of data. So we, at first step of data cleaning, we uh, consider the situation that pairs of features with a large covariance was removed from our data set, and after this manipulation we got a total that only 200 features. Another step it is data preprocessing, the aggregation of features. In each step, the entire set observation was divided into successive intervals, for each of which observed number of errors was fixed, and the feature vector was replaced by the current average value of the intervals. In the second stage, the reduction of the number of features was performed by method factor analysis, and at last, at first stage, clustering of reduced data set in factor space was carried out. After that steps, we After these steps, we obtained the results of factor analysis of our features. We obtained only 5 factors. It is demonstrates that the hidden factors covariance matrix demonstrates the high quality of previous factor analysis. So we construct our model only from the 5 hidden factors. After that, we do the clusterization of this data in the factor space in order to obtain the smooth uh, model of the flow rate. Clustering in factor space was carried out in order to reduce the number of kernel function. In resultant Fairlight model, while center of clusters were chosen as center of the kernel components, and the average values of number of errors of each clusters were used as measures response function. And after that, they demonstrate the results. It is estimated regression model of the far right. It is, of course, only projections of the sum axis on the first, second, and other factors. It is the base kernel models and the smooth kernel models. Mean average error estimated from the not, of course, not from the training data set, but from the test data set, demonstrates that smooth kernel models has acquired quality and may be applied in order to construct these models. And the brief conclusion: obtained results indicate that power rate kernel model regression model built using machine learning technique provides the opportunity to analyze influence of a large number of technological and both empirical effective factors and successful approximation of complex dependence of high accuracy. The results of computational experiments show that cluster-based smoother model demonstrates slight decrease in accuracy, but avoids spotty oscillations. It is very important from the point of view of obtained the realizable model, and as well as overfitting and more stable to outliers and noise. And further development of proposed approach may be connected with the developed methods and algorithms for power rate and power themselves forecasting based on combination of time series predictions method and proposed method of the identification of the power rate function. Thank you very much for your attention.
Thank you so much for your presentation. Welcome, colleagues, for your questions. Short question.
Yes.
What about kind of equipment or any system in context Industry 4.0 or in context of predictive maintenance for 4.0? It is very important trend for this concept. Your opinion about type of such equipment where your approach would be very useful.
Yes, of course. We consider this idea only as a part of the main problem of the power rate predictions. I think that it may be used as a combination of the different methods. Some method connected with the identification of power rate, another methods it may be connected with the prediction, in time prediction, so forecasting of the measured signals from the equipment. We consider the real problems of the semiconductor process in the data set was this data set was connected with the describing of type of sensor was used in this field, but from my point of view it is necessary to use pre-filtering of this measured signals, and then combination of the identification make it give the situation of the complex predictions may be considered as a part of the decision-making maintenance problem. I think that may be very important and very useful for the complex production system control.
Yes, thank you. It's really right. And
thank you for
I maybe just suggest analyze tools which are which exist now for such kind of task. Maybe your approach could be embedded into or could be added to existing tools. It would be really very important for practical in practical issues. Thank you. Any other questions, colleagues?
Thank you for your.
No. Thank you very much, Professor Lubchik, for your hard work during the presentation.